Alright, so check it out. We're going to take a look at the horizontal asymptote and the vertical asymptote. The vertical asymptote is pretty easy. All you got to do is take a look at what the denominator is. 2x plus 5 cannot equal to 0. Sorry, there we go. 2x plus 5 cannot equal to 0. So therefore, x cannot equal to negative 5 over 2. Negative 5 halves, that's the same as negative 2.5. So here's my vertical asymptote. As far as the horizontal asymptote goes, I basically can disregard this 1 and this 5. And I only really care about the leading terms, not just coefficients, but the leading terms. The leading terms in this case is x over 2x. So essentially this is equal to, it's not about, it's equal to 1 over 2, because the x will cancel out with the other x. So I know that this graph actually kind of tapers off to 1/2. So I think that the graph kind of looks like this. Why don't we check out decimals to see what we got? Alright, so here we go. It's x plus 1 over 2x plus 5. Oh, I think no, I didn't screw up. You're right. It's for some reason they graphed this thing a little backwards. Here's the 0, and so I went back 2.5. That's exactly what that shows. It goes to the right 2.5. And let's see where it let's zoom in really well. Let's see where it tapers off to. So it looks to me like it gets closer and closer to this line up here. Does it ever touch that? Let me see. Alright, so this is 1 and this is 1/2, so it's going to get closer and closer to that line as I go out that way. If I go the other direction, it's going to go closer and closer to that line. And I actually screwed it up. The graph looks like this. It starts over here and it goes here. So let me just kind of do this. There and there. Alright. How do I know how that thing looks? Well, I know that what I would do if I were you is I would plug in a test, and I would say, well, what if x is equal to 0? If x is equal to 0, and I'm going to take a look at this, x plus 1 over 2x plus 5. Okay. If x is equal to 0, then what's going to happen? Actually, you know what? Let me do, yeah. If x is equal to 0, then what's going to happen is I'm going to have 1 over 5, 1/5. So I know that the horizontal asymptote happens at 1/2, and I know that 1/5 is smaller than 1/2. So if I'm standing on this side of the graph, right here, then I know that this thing is going to be close to, it's going to be underneath the horizontal asymptote. If it were above the horizontal asymptote, then my graph would look something like this, because I would want to catch the part that's above the horizontal asymptote. I don't know if that makes sense to you. Maybe we can do another problem and see if we can get you guys to understand what's going on here. No. I'll tell you what, why don't I record, alright, why don't I explain this to you a little bit better. What's going to happen is my graph, I have a vertical asymptote and a horizontal asymptote. And what I did was, I know what this horizontal asymptote is. This is happening at 1/2 or 0.5. Okay? And here's my y or my x-axis, and here's my y-axis. And here's my asymptote. So this is an asymptote and this is an asymptote. So I have two options. My graph could either look like this, or it could look like this. And the question is, which one is it? And my answer to that is this. I tested out a point on there. I just plugged in x equals 0. And I got that x equals 0 gives me 0.5. Or 1 over 5. So that's 0.2. Which I know is below my horizontal asymptote. So I know that this graph has to catch that point right there. So I'm going to assume that that graph looks like that as opposed to this one over here. Does that make more sense? I hope it did. All right.